Good morning, everyone, and welcome to the Amazon Web Services Data and Analytic Virtual Series. We are just giving participants a few extra minutes to join. The webinar will start very shortly. Thank you. Good morning, everyone. My name is Kamran Habib, and I'm a senior solution architect at Amazon Web Services, Australia and New Zealand, based in Melbourne. Thank you for joining the AWS Data and Analytics Virtual Series. In the spirit of reconciliation, Amazon Web Services acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. Over the next few weeks, we will be showcasing how businesses in Australia and New Zealand are using data as a strategic asset to offer better products and customer experiences, make better business decisions, and find efficiencies to reduce costs. Today, we are very excited to be joined by Environmental Monitoring Solutions and AWS partner DiUS as we showcase, learn how they collaborated with AWS to drive greater efficiency and environmental compliance for petrol stations by reinventing data collection processes. We will also have a Q&A panel style discussion with all speakers and give you the opportunity to ask our panel questions. Today's event will run for 45 minutes and we'll allow some additional time for Q&A. All participants will be on mute to ensure the session runs smoothly, but you will be able to type questions in the questions box on the GoToWebinar panel. Our speakers today are Russell Dupuy, owner and managing director of Environmental Monitoring Solutions, and Zoran Angelovsky, principal consultant IoT at DiUS. So I would like them to introduce themselves now. Thank you.
Thank you, Cameron. Welcome everybody and hello. My name is Russell Dupuy, as stated. I'm the owner and founder of Environmental Monitoring Solutions, and I'll be opening the first part of the presentation. Over to you, Zoran.
Thanks, Russell, and thanks for the introduction, Cameron. So my name is Zoran Angelovsky. I'm one of the principal consultants at DiUS Computing. Predominantly, my area remit is in the area of IoT, or the embedded device space. And I'll be talking about the technical solution today that we help Russell build out this platform.
Thank you, Russell and Zoran. Before we start though today, we will launch a poll question to the audience just to get some insights from our audience today. Thank you. We will kick off with Russell, who will start with EMS's approach to environmental monitoring, fuel theft, occupational health and safety, and customer experience. Over to you, Russell.
Okay, thank you, Cameron. Just give me a moment and I will navigate my screen. So welcome to the audience. Thank you for attending, and hopefully today's presentation will provide an insight to our digital transformation. Before I get into that and talk about the vision, I'll talk about the process of the presentation. So we've got two parts. I'm going to talk about what I'm going to describe as our entrepreneurial journey, and that's the process and decision making on how we were going to recreate our technology from old technology and take us into the future. Part B will be Zoran, my counterpart here, and he's going to then talk about the technical journey in terms of how we had to create the technology to meet the vision. So before I do that, I'll tell you a little bit about who we are as a company. Environmental Monitoring Solutions, I founded in 2004. I'd been in the petroleum industry now for probably 30 years and specialising in man-to-machine automation and fuel system leak detection. So that's our core part of our business. So primarily we provide leak detection services to petroleum retailers around the world, and our job is to detect the early onset of a fuel leak in tanks underground that are buried. So up until the last 5 years, the analysis services we were providing was looking primarily at data that could be a week or a month old. So you can imagine the time latency to detect a problem and report a problem was not really ideal. So we had a vision that what we wanted to create through our automation experience over the last 30 years was, what if we could knit together all the technology in a retail environment to use fact data, not historical data or periodic data, in a way that we could then provide and drive predictive analytics that would drive actionable insights for our clients in real time, so they could find theft and fraud and leaks and a range of other things I'm going to talk about in real time rather than past time. So part of that journey I'm going to talk about is the process that I had to follow as a business owner, and I'm going to call it the entrepreneurial process, because what we were faced with is having some very solid old technology, but making a considerable investment in new technology, and we're talking in the multi-million dollars, and ensuring that we weren't building a better mousetrap just for the case of a better mousetrap. So whilst we had this passion and drive for technology, it was a case that we had to ground that back down to, let's just do a reality check and make sure we understand the problem we're trying to solve. Can we solve adjacent problems to those key problems? Do we understand the customer journey? We did some customer research, and then bringing that together to a business decision to say, does this stack up? Does it make sense? And then go back to market and test that. Is someone actually going to buy it and value it? So moving on in this regard, so I want to now introduce you to Fuelsuite. Fuelsuite was our cloud creation. It's our next generation platform for real-time data analytics. So the process we're going to talk about here firstly is identifying the key tenets of what we solve for our clients, because if we don't focus on that and focus on the tech, we're missing the target, if you like, of who's going to get the value out of it. So Fuelsuite is about maximizing the return on fueling environments, and it does focus primarily on the fuel side of the business, not the convenient and the dry stock. That's what I'm going to talk about a little bit later on around the fuel station of the future. So primarily it's about driving fuel station efficiencies across the whole fuel system. As you can imagine, on a petrol station, there's dispensers, there's HVAC, there's vending, there's underground assets, all disparate, some analog, some digital, all have proprietary protocols. How do we bring that together where they can drive more efficiency across the network, given that petrol pricing is hovered over by the ACCC? The other key thing is minimizing environmental impacts. As you can imagine, the average service station actually stores between 120 to 160,000 litres of liquid asset underground. So one of the key concerns here is if that leaks and it finds its way off-site to other properties, that's a major concern. But if it finds its way to groundwater that can then migrate off-site to surface water, we have a very different problem. To give an idea, it takes about a traditional 44-gallon drum of petrol can contaminate 1 million litres of drinking water. So environmental impacts for some countries that have potable drinking water is a significant issue. We then looked at how can we gather data, like I said, from all these disparate devices that have different analog, might be analog, digital, may have timestamp, may not have timestamp, have walled gardens around their protocols, and that's where we introduced the IoT versus the cloud. One of the other key decisions here was looking at the market, we had to select a cloud platform that also supported and integrated with an IoT platform. So, you know, I guess I'm waving the flag for AWS here, but about 5.5 years ago when we embarked on this journey with DiUS, who significantly helped us make some of these core decisions around what platforms to use, we felt at the time AWS Cloud was right up there, but when it came to the IoT platform, they were there, not almost there like others, which meant for us they were ready for market, and time to market was very critical. The other thing I wanted to mention there about extensibility and open solutions, one of the challenges we had was moving into new markets like China, India, Southeast Asia and the like. There was this real concern around data protection. They wanted data to either stay on-prem, in or in country, or on their own AWS infrastructure. So by adopting the cloud solution with AWS, it allowed us to stand up an instance anywhere in any availability zone rapidly. So that was a key consideration. We've got case studies here where clients are enjoying up to 500% return on investment. I will qualify that's not on all clients. It's certainly prominent more so for theft and fraud in that regard. So as a proven product, it's been running 5 years. We've got a global footprint now, and we note some clients there, as you can see, in varying degrees across the world, and enjoying strong growth with Fuelsuite. So I'll now take you back where I said I would, which was what I'm going to call the entrepreneurial journey. We've got Fuelsuite, it's a proven product, it's been tested in the market, and it's rapidly scaling. We had to go back and think about what are the problems we're trying to solve fundamentally for our clients, who they recognise. But what we wanted to look at is who in the business has to work with solving those problems, given that a lot of the problems we have don't involve one person. They'll involve multi-contractors, and investigations can go on for extended periods, as well as multi-department. So the key things we were looking at is health and safety, the use case and problems to solve. Now, curiously, in COVID, we've had approximately about a 350% increase in user subscriptions to our Fuelsuite platform, simply because major clients have people working remotely and they want to get access to real-time data to make real-time decisions where they can't get in the car and drive, or they can't pick up a phone because there may not be an operator on site for unmanned sites. Improving fuel system performance, which I discussed, enhancing customer satisfaction. So all of us are consumers, and if you filled up at a petrol station, which I'm sure most of you had, you might remember these annoying experiences. You've lifted the nozzle and it's not priming. You're waving to the operator and they're waving back to you, and you've got that minute or minute and a half delay between the authorization process. And there's a number of pieces in the technology chain that can thwart that, if you like. Furthermore, when you put the nozzle into the car and you have the backflow turning the trigger on and off, which means you're not getting your 38 litres a minute and you're standing there for an extended period, which is frustrating. Everyone knows buying fuel is a grudge purchase. So one of the key things here is how can we identify slow flow and in the technology chain what's causing that, so rectification can occur. Driving, improved customer satisfaction. So identifying and resolving fuel system losses, which I'll talk about a little bit more, is another key use case and problem to solve. Maintaining and improving compliance. So in a retail petrol environments, there's 3 levels of compliance. There's the EPA that has regulations around thou shall not contaminate the environment. There's the ACCC that, as you will see in the press, is hot on the heels of price compliance, ensuring what the price sign says versus what the pump says must be the same, and you must report your pricing. And the final one is when you pull up as a consumer and you buy your 10 or 20 litres, do you really get 10 or 20 litres or something more or something less? So there's some compliance around that. So that was part of our consideration, is understanding and how we can improve that. And the final one is, well, the final one, but the last frontier has always been logistics. So you can imagine a road tanker that can be a B double or a single rigid. it will carry 42 to 60,000 litres. It leaves a terminal or a depot or a point of origin and drives anywhere from an hour to 15 hours in Australia, one way to deliver fuel. Knowing that that fuel can arrive on site and take that fuel is super important. Otherwise, they have to either redirect it, which is very complex because they need to know what other adjacent site in that perimeter can take that fuel, or worse, they've got to haul it back, which is hugely expensive. And the final piece is around bringing all that together around improving asset maintenance. Starting with the real problem, the hard-hitting problem, which is our core platform, I guess, is just to set the scene. Leaking tanks is a significant global problem. First reared its head, I guess, in 1984, where there was a 60 Minutes documentary that highlighted a little town of Richmond in Rhode Island in the US that had a one tank leak on the site, and it contaminated the entire town's drinking water. Reagan at the time, the President Reagan at the time, decided to put some regulation in place, and by 1998, every retailer or storage owner of fuel systems had to comply. In that time, they have closed 1.5 million tanks. There's been over 380,000 cleanups at a run rate of about 19,000 sites per year. Now, that is old information. So to put that in context, Australia has about 6,500 retail sites. That's 3 times our market they're cleaning up each year. So in 2004, Australian EPA thought it was a good idea and introduced best practice in Victoria. And up until about 2008, that promulgated to every state and territory, now having regulations and finding problems as well. Again, to put the lens a little bit further on that, in the US, which is the only country that you have to report and monitors a leak right through to conclusion. In Australia, that's emerging, but it's not required right now, and it's not reported. But to give you an idea, over 500,000 fuel system leaks. So you can imagine the contamination to potable drinking water, adjacent properties, and I'll give you some examples further on in the presentation of how catastrophic this can be. Talking about safety on a forecourt, so I'll bring your attention to the gentleman in the high vis and the approaching car here. This is a common problem. So we're showing this one because it has a happy ending, but what you can see there is a range of health and safety issues. We've got a contractor on site who didn't adhere to health and safety issues and what could have created, well, a death incident. So this kind of highlights, when you can see the activities going on site, a number of issues that concerning moving vehicles. You've got consumers or the general public on site. They're at risk, contractors are at risk, the operators at risk. We often see criminal activity, especially around people under the influence of drugs coming onto sites, smoking cigarettes. Keeping in mind what you just saw there was the gentleman working on bending down, working on a tank, and as he opened that tank up, that cap, he would have had a flurry of saturated vapor come out of that tank. So if someone was walking past having a cigarette, you can imagine it's not going to be an ideal situation. The next one really shows what can happen when it really goes wrong. This is an incident in Maddington, WA, I think about 2008. And what you're looking at there is obviously a pretty big fire. And so let that play out. So what we're looking at there is what's happened here. A tanker has arrived on site. I can't talk too much about the particular details, but what happened there is the tanks couldn't take what was on board the truck. In decoupling, there was a spill, above ground spill, and the conditions were right. We had a fuel, we had a source of ignition, and we had oxygen, and that's what's created the explosion. A raft of OH&S issues were present at the time, and unfortunately, when you look back on that video, it was the very good work by the fire brigade to keep the other compartments on that truck cool so they didn't explode. So we only had 2 compartments explode. If the other 6 had exploded, or 8 I should say, on that truck, that would have been a very different incident. So if you can imagine, if we can then get to the source of truth, get to the fact data in real time, do just-in-time management, just-in-time checking all the time, these are the type of incidences that can be averted. Again, moving along, we knew the problems we wanted to solve. They're real problems. We understood the business, the use cases, but we wanted to go test that out fully. So what we did is we embarked on a research journey with DiUS's UX team, who were really super helpful, that allowed us to sit with clients and ask the questions about the problems they have, but also ask what else is related to that, and what do they do to solve these problems, or just process the problem. In fact, we were videoing people, and what it gave us was an incredible insight to what we call the customer journey mapping for existing customers and customers or potential customers for us. And without reading out all those tabs there on the screen, it was quite considerable in regard to what they were looking to do. So we took that information and distilled that down and then put it into a package that could show the convergence or the Venn diagram, that we could then see there's a real value proposition here if we could bring IoT and cloud to the forefront and progress our clients in this digital journey of transformation to actually knit it all together and solve these problems. So we put this together as the business case to take to Major Oil and say, hey, have you looked at it this way? And the convergent points is where the real value is, because the other bubbles are really just about what they're doing today. But by knitting it together, it allowed us to really give a clear picture of how a data transformation or data journey, as you might use that, could really drive significant benefit to their business. So I went along a little bit further and saying, well, let's make sure we're not building a better mousetrap, because I can't afford to build a better mousetrap that nobody purchases. So we went back to market, and this took about 4 years to really get an idea of not what the global market size was, because it's very, very large, but what is actually the addressable market? What are the markets and regions that actually have the underlying technologies that we can knit together to create this digital transformation that will take them from historical, periodical to perpetual data that drives actionable insights? So as you can see, it's quite substantial. And we're now prototyping or piloting in many of these markets and scaling quite nicely. The other part was around the desired outcomes. So as I mentioned, we did a lot of customer journey mapping, developing the personas for the users, and that's where we did a lot of work with the UX UI to make sure that what we built would be used, that would then create ongoing value, and the user would continue using it and hopefully ask for more. So that was a whole body of work, and probably not enough time in this presentation to get to, but as you can imagine, as technology people, it was multi-platform, making sure it spun up quickly, making sure it was efficient and super fast. That was a key requirement, considering that a lot of the data we're looking at in the cloud or in our desktop, we're actually slicing and dicing significant volumes of data in real time. This is almost where I hand over to Soren. So just to give you an idea of the journey, it was in 2014 we embarked on this journey to go from web-based or on-prem applications to a cloud and the creation of Fuelsuite. It was in 2005 that we then started our IoT project, where we said, we need to design and proof and pilot something through to productization. And that's where the DiUS IoT team really held our hand and allowed us to go into an area we didn't know well at all. And what we ended up doing was creating and productizing the first IoT product here in Australia on AWS platform. That went out to about 1,000 sites in 2017. And that was the tipping point, because what we realized is it did work, it was creating value, and the customer loved it. One of our first customers in an ideation was telling us, when we were journey mapping with them, they thought they would have 6 users. We allowed for 12 users. I think today, and I know my dev team's on this presentation, so I can't say false truths, I think we're over nearly 400 users for that one client. So it's testament to that we hit the mark in terms of usability. That then led us to saying, well, how do we address the global market? Because our first IoT POC was focused on the Australian New Zealand market. And what we wanted to create was a edge IoT device that was primarily agnostic at the physical layer. So the idea there was just protocol implementation. And we achieved that and deploying overseas. And we're about to deploy, probably in the next 6 months, our 3rd iteration or version of Fuelsuite. This is, again, about the, we talked in the openness about the petrol station of the future. And this is just a slide to give you the idea of where we're headed. So I've talked about what got us here in terms of commercialization and business decision making. We're going to talk a little bit more around about applying data science into the future now that we have that richness of data and we have that history of data to go and play with. This point is where I hand over to Zoran. Thank you.
Thanks for those brilliant insights and amazing story, Russell. Again, as Russell mentioned, we'll hand over to Zoran from DiUS, who will provide some technical perspectives into EMS's innovation. Over to you, Zoran.
Thanks, gentlemen, and particularly thanks, Russell, for going through that. So today I'll be really talking about the technical solution, and for the most part, I'll go over what we actually built for Russell and present that really through an IoT and a data lens. So what I'd like to do is really pick up the story or that journey that Russell had up on the screen a little earlier. I'd like to pick up the story in that sort of 2016 and 2017 period where Russell came to us and really he was looking for a major uplift in data collection. And that data that he was looking for very much focused on some significant gaps that the industry had surrounding the fuel data. So that's where we'll be focusing on today. Now, before we actually go into some of the detail, I thought it'd be worthwhile just recapping on the problems that Russell was looking to solve. Although we have a very much technical focus in what we do, regardless of that technical implementation of the data we collect, really we still need to bring back what we are doing to a lot of these issues that Russell was in effect looking to solve. You know, those significant environmental impacts where a subtle fuel leak can go over a long period of time, it's undetected, and it causes that a very significant and major environmental damage. And of course, we saw some of the health and safety issues that do confront the general operation of these fuel sites as well. So before I go into the detail, I thought I'd just present a little bit about what we had to deal with when we first approached this project. So quite often when you hear about IoT and data projects, really it's around modern sensors, modern internet connected sensors with a very convenient API that you can attach to when you're up and running in a very relatively short time frame. Well, this project really was around a very large installed base. So retail fuel outlets, of course, as you know, have been around for many years, decades, and really these large fuel companies have invested a great deal of money, tens of millions, if not hundreds of millions of capital that's occurred over that period of time. And it's quite a mature industry from that point of view as well. So what we were confronted with was really a lot of old and new equipment, but also old and new protocols, and a lot of disparate protocols as well. Now, for the most part, the equipment is built to standards. It is largely compliant, and what it measures is actually measures it really well. So the data that it actually obtains for levels and temperature and so forth, it does really well. And again, for the most part, it is functional. However, as you can imagine, it's been built out over a long period of time, and quite often the equipment is quite old. There are some rough edges. Now, I'll go into just a couple of examples that we actually found along the way, or very early in the piece, actually, whilst we were trialing. So one of the things we had to do was actually monitor the communications between the point of sale equipment and the pump communications. And what we actually found was the comms wasn't as clean as we thought it would be. So I've just popped up there an image of a trace or an oscilloscope where it should be largely a square wave, but as you can see, it's anything but something close to a square wave. And one of the other things that we found fairly early in the piece was that a lot of the tank gauges that are pictured there, they actually didn't keep time particularly well. So if we had a data set come through and it would tell us it was 2 p.m., you know, it may very well be relevant to an 11 a.m. Time slot. And that's quite understandable because for the most part, a lot of the tank gauges have been out there for a long time. They hadn't been connected to any external source to maintain time very well, so their clocks had drifted. And these are all the sorts of things that we actually had to be able to cope with. So what was the task? So what did we actually, what were we actually tasked with from Russell to do? Well, essentially it came down to connecting a lot of on-site data that was available, but fundamentally we needed to do it in a scalable and cost-effective manner. But the idea with then doing that was really to build a capability where we could anticipate problems before they actually occurred. And to do that, we needed data. Now, the state of play in the industry back then in that sort of 2016-17 period was that a small proportion of the underground tanks were actually connected, somewhere between 10 and 20% of the tanks. The data was only uploaded once a day. And again, we wanted a significant uplift in that. So what we wanted to achieve for Russell's customer base is 100% coverage, basically, of all those fuel tanks. But importantly, we also wanted data uploaded every 30 seconds. And what that gave us essentially was near enough real-time access to what was happening at those fuel sites. Now, to close the loop on that data, so at this point, we understand what's coming into a fuel site. We can monitor the tank levels, but what we don't have is what's actually coming out of those tanks. And that is that ability to be able to connect and understand what's actually coming out of the tanks through the pumps themselves. Now, some of that information is available at these fuel sites because they have point of sale terminals and things like that. But accessing that data certainly does have its issues due to some of the commercial arrangements at the sites. But fundamentally, some of that equipment provides an abstracted view. So it's not a source of truth of data coming from those pumps. So we needed a way to actually collect that pump data. So with that data, what we now have done is actually closed really the loop, or closed the cycle on that data, because we know what's coming in, we know what's underground, and now we actually know what's coming out of the tanks. So our job of reconciling and detecting issues has all of a sudden become a lot easier. And the last item that we actually had what was there to develop was really to connect the price boards. There are, as Russell mentioned, some rules around what you actually present on your price board and the price that's actually presented at the pumps. But the other thing that it actually helped out with significantly actually was remote stations that were unmanned, where there was no capability to adjust the price for those unmanned stations. And so we built that capability as well. So what did this actually do for the business? Well, at the time, I guess prior to Fuelsuite, a lot of the industry was very much working in a reactionary model. So an incident would occur, someone would go out at some point, address that incident, they'd collect the data, and it was very much reacting to something actually occurring. What we wanted to do is, through that major uplift in data collection, we wanted to shift that around. So what we really wanted to do is collect that data in real time, continually monitor that data, but then be able to ideally anticipate a problem, such as a subtle fuel leak, let's say, that might occur over a long period of time, or some of the actually more obvious ones where, as an example, water contamination of fuel. So if there was an incident where a vehicle was damaged through the water contamination, it would often take up to 3 months where the incident occurred for the data to be looked at or to be found, and then for that case to be closed out. So what we did through this, and also through the live data, as soon as there's water detected in the fuel, almost 30 seconds later, a message actually goes out to the person that can do something about it, and they can actually go and action that so that we minimize any damage, potential damage that might occur from that particular incident. And they're just a couple of examples. Okay, so this next slide really talks about how did we go about building Fuelsuite, and I've called it good data here. So I'll go through that. Essentially, it really starts off with defining the problem, as most projects, but also understanding the data required for that. And the way we go about that is really we talk to the domain experts. And EMS are, I guess, well and truly experts in this area, having been in the industry for quite a long time now, multiple decades, I guess. The next thing that we look at is really, once we understand the data required, we really need to know how that data is going to be used. There we tap into our user experience people, or our UX people, as we would call them. And essentially, they are the voice of the customer. So they are the voice of the person that will be using this platform, and they help us interpret how that data needs to be used, or how it should be used, and who it needs to get to fundamentally. Now, once we know how that data is going to be used, we actually need to work out how it is we're going to detect the particular parameter that we're looking to monitor. And really, that comes down to choosing the correct physical devices. So what's needed, how they're going to operate, are they battery powered, are they AC powered, and how do they actually meet the requirements of those other two objectives that we have above showing just there. So that's where we tap into our embedded team capabilities. Essentially, they're our device people, or the guys that understand hardware. So once we're actually detecting, we know what sensors are out there. We know how the data is going to be used. Well, we need to get it to a location somewhere where we can process that data and do something with it and get it to the right people. Essentially, it needs to occur in a timely, reliable manner at scale, and I could go on with more items there, like security and so forth. And really, the people that we tap into there are our IoT and cloud experts. So once we've got the data in the cloud, well, we actually need to then present the data. Now, how do we do that? There are lots of tools out there. We would like to leverage those tools and frameworks, and that's where our web developers come into the picture. And lastly, we now have access to data, but what is our strategy with that data? So is it going to meet our requirements today? And what does it mean for using that data into the future? So are we storing it correctly? Are we taking data into a particular data lake, and are we dropping off some metadata that could potentially limit the use case for that data down the track? Or as another simple example, we may have some time series data. As soon as we choose the sampling rate for that time series data, we are potentially locking out the use case for future uses of that data. And really, the experts that come into the picture there are essentially our data science team. So really, building Fuelsuite for good data essentially was a team approach. It leveraged the domain experts, the DS capabilities, and of course, we also tapped into Amazon's capabilities, given that they were providing that underlying infrastructure for the platform. So really, actually, this is quite a complex task, because it requires bringing all of these people together, and companies don't always have those capabilities. So in that manner, it actually it does become a little complex, but this is where we come into the picture, and we can bring all of these resources together and actually produce a good outcome for the data. Okay. I'll just briefly talk about what our approach is for IoT. I won't go into this too extensively, other than to really say that we've sort of identified 8 core areas of the steps that we take into whenever we're looking at a particular project. Now, how much of this you actually leverage and how far you go into it really will depend on where you are at with your product. If it's very early in the piece, you may be proving a business idea, and you may then want to stop early and then look at tech that you might need. So it may involve some experimentation and so forth, and you continue along that journey as you're building confidence in your product, in your idea, as you're proving out that idea, and then which may lead to the detailed design step, and the manufacturing, and so forth. So I'll take a snapshot of this and what we did early when Russell was looking at his IoT journey. So for Russell, really, we needed to show a critical capability, and that was related to obtaining that pump information. But fundamentally, the customer or his client had identified that obtaining that data needed to be non-intrusive and independent of any mechanism at that fuel site. And there was a lot of sensitivity around this, and the reason being is that there was potential there to disrupt that sales cycle. And really the client wanted to be confident that we weren't going to disrupt the sales cycle. So that was a key point that we needed to show. So we structured that early part of the project around a proof of concept. It kicked off late in 2016, so it was late November. 6 weeks later, by about the middle of January, we had a proof of concept running, and we demonstrated to the client, and that kind of gave us that big tip to give us the confidence to then move to the next stage, which was field trialing and exploring the product a little bit further. And the images that I've got there are essentially that first proof of concept. So top right is the first generation hardware that we developed. It was used to prove out that we could actually monitor the pump data in that non-intrusive manner. And in the bottom right corner there is essentially an entire fuel station. There's a tank gauge, there's the pump communications module that I had there, there's a simulator for the pumps, a point of sale terminal with the laptop there being the display for the point of sale equipment. So that then got us to the next point, gave us the confidence to build out the solution. So what did we end up building? Well, essentially it was around connecting those on-site equipment or the data, or sorry, the devices that gave us the data, the underground tanks, the pumps, and the price board. We connected that over a cellular network into the cloud infrastructure and had a web presentation for our analysts and the other users that Russell spoke to earlier on. Now, what was underneath that? Well, they were all the things in our Internet of Things, if you like. So it started off with the custom hardware that we built, the tank gauges, a product that we called FuelScan SDA, which was essentially a station data aggregator. And that really hosted our IoT SDK from Amazon, and we connected that into the cloud. As it turned out, there was a cellular network, but really we could have connected that over in any particular network. It could have also been satellite, whatever, depending on our needs. So let's look a little bit more under the hood. And I'll talk to a little bit about the end-to-end architecture here. So at one end, we had our sensors going through an IoT core that was provided by Amazon, and then the web presentation at the other end for our users. So on the far left, we had our things. These are our things in our Internet of Things. Again, the price board, pumps, and the fuel tanks, connected through custom hardware that we built to monitor the pump data, our station data aggregator, which was, I guess, housed at the remote site at the fuel station in this case, connected to the AWS IoT infrastructure. Now, all of these components here come pre-canned, if you like, from Amazon. What we do is we take the IoT SDK, we adapt it to our target hardware platform. In this case, it's operating an embedded Linux operating system. Taking that IoT software development kit or SDK and adapting it to an operating system such as Linux has become a very, very simple exercise. And all of a sudden, we have a complete end-to-end connection. It's not just a basic end-to-end connection. It gives us all of the additional functionality that we need to secure the device, a mechanism to talk between the two ends. And as it turns out, it's MQTT here, the protocol that we use. It's a light protocol, so it's great for bandwidth constricted environments. But fundamentally, the point here is that all of this is based on existing libraries. So once we pull in that SDK into that remote end, we have this capability very, very quickly and early into the piece. Now, once we get data into the cloud, in through the device gateway, it actually takes two paths. We have our IoT rules engine, and that predominantly deals with the data that we are collecting. And it gives us an ability to route that data that we are collecting to any other service that we might wish to tap into from an Amazon perspective. And I'll talk to those just in a second. I'd also like to mention the IoT shadow. Effectively, it's a shadow of our end devices that are in the field. And what that does is it gives us the ability to be able to configure those devices in the field in a very convenient manner. So now we have two mechanisms, one that deals with the data that we're actually collecting, the other one that deals with the management or the configuration of the devices in the field. So with the data, we can very simply, through IoT rules, route the data to any of the Amazon services we wish to tap into, and fundamentally we can change that as the evolution of the services that we're delivering without affecting any of the downstream firmware. So we can actually change that routing according to where upstream requirements are at any point in time. The shadow, on the other hand, gives us the ability to manage and configure devices. As one example, your devices may be coming off the production floor, you're rolling them out, you can actually pre-configure those devices according to their specific needs. So if you have devices in different regions, they need to be configured differently. You pre-configure them before they're rolled out. And as they turn up, as they come up, their configuration will be reconciled and they're up and running. Now, the rest of the Amazon services are really too numerous to list. So I've just highlighted a few of them there. There's the likes of the Kinesis streams, the Firehose services, the Elasticsearch services, the notification queues, and so forth. There's a whole host of those that we tap into. Beyond that, it's really about the users of that system. That's kind of that end-to-end picture, looking a little bit under the hood. So now we actually have an end-to-end connection. We can access the data. But if you recall, we really still have some challenges. And those were around the numerous protocols that we spoke to earlier, some of the physical layer communications issues that we were confronting, and really some of the other things like the data, or sorry, apologies, the time not being kept particularly well on some of the devices that we had out in the field. Now, as you can imagine, this is actually quite bad for data and any subsequent analytics we wish to perform. It makes our job just a little bit difficult. So how do we go about some of these things? So I'll present this in a few different ways. Really, it's about how do we tackle the product and market fit, and how do we also get around some of those issues that we were talking about, and how do we support, at the same time, support the business growth. And we'll look at it through a couple of different lenses. We'll look at the business challenge, what it means for the device, and how we went about solving that particular aspect of the solution or of this particular issue. So how do we go about meeting the user needs? Essentially, we had some fundamental business needs, but at the device level, really we needed to understand how that data was going to be used, how frequently we needed the data. Did it need to be real time? Who needed to see that data? And the solution to that was really that team approach, tapping into the domain experts, tapping into all those various skill sets that I spoke to that DiUS brings to the, to the table, and so forth. The next item I've got here is really accessing specific data that you may need. And in this case, it ended up being the pump data. There was a big gap in the data, and we needed a way to actually solve that. So essentially, we identified a proof of concept, we demonstrated that we could monitor that data in a non-intrusive way, and that was key to then progressing the project further. Now, how do we tackle the challenge of getting to market quickly, but also keeping an eye out on international expansion? And there's some strategic decisions that we made here. At the device level, really we had lots of different protocols and physical layers that we needed to contend with. We had lots of different customers in Australia, potential customers overseas. How do we balance that up at the same time meeting that, getting to market very quickly as well? So really we split the product evolution into a couple of different areas, if you like. We produced a generation 1 product for the deployment, and really that captured that early market penetration that we could achieve. With that product, I think we had some 25%, or Russell achieved some 25% market coverage here in Australia. Now, that actually gave us the time to roll out the product, but importantly, it gave us the time to then explore those other markets more broadly in Australia and overseas that Russell spoke to. So what we did is then developed that custom hardware that we spoke to earlier, and we made it largely agnostic of the physical layer. What that meant is that we could then go to China, Indonesia, just to name a few of the markets that we've gone out to, South Africa, New Zealand. It meant that rather than developing a new hardware product, we could go out to these markets with a software change and then have a product working in those markets as well. Now, fundamentally, the other thing that we built into the platform was that we ensured that it was going to be extensible. So we built in those remote upgrade capabilities for our remote devices. What we also did is we left capacity for the remote devices to be able to adapt and attach other sensors. And of course, at the other end of the platform, the cloud end of it, we have all of those resources that we can tap into from a cloud point of view that Amazon offer us as prepackaged services that we can quite readily tap into. Lastly, we saw that we had some issues in terms of how we handle data and the reliability and the consistency of that data. Really, at the device level, we saw that we had some physical layer issues and some of our devices didn't particularly keep time very well. And the way we manage that is, as far as practical, we like to keep the data raw. We try not to change the data, and we store the data in its original form, not dropping off some of the metadata. If there's an issue with that original data set and it needs to be recalibrated, we can actually go and recalibrate that original data. So where practical, where we can, we stick to the data in its original format as far as we can. Now, for the poor timekeeping that we had, I've left it there very simply, and I've simply said we've timestamped the timestamp. What I mean by that is that we take the data set that we get from a tank gauge that was keeping poor data, we keep the original timestamp, we keep the data that it collects, and we added another timestamp to that. Now, the additional timestamp we added was done through our station data aggregator. It kept time very well because it was internet connected, so we leveraged timekeeping protocols. And really what that meant is when that data was then presented in the cloud, we can reconcile that data that wasn't timestamped originally particularly well with events that would occur. So if we had an event like a large delivery to a site, well, we could actually work out what the delta was there, and fundamentally we could adjust that time in the cloud by not having to adjust the time in each of the devices, which would have taken significant effort in going out there. So I'm very close to the conclusion. Really, what's the story look like so far? Well, essentially we've achieved that, moving away from that very much that reactionary model to that proactive model. We have a very strong deployed base out there now in Australia and other parts of the world. We deployed the Generation 2 product that expanded our capability to tap into other protocols, which was a key enabler to go into overseas market. And effectively, right now, we have an extensible system which allows us to take the next step. So where to next? Really, it's more about the data story. It's tapping a lot further into the analytics capabilities, but also build out the story where we leverage artificial intelligence, machine learning, and all those other modern data techniques that we can tap into. But fundamentally, where we're also at is really looking at, so far the story has been about the fuel operation, but we can now also look at non-fuel operation at a retail fuel outlet. And this is where I hand over to Russell, where he actually will share some of his vision in terms of what a retail fuel industry will look like into the future. Thank you.
Thank you, Zoran. That was excellent and very insightful, and hopefully gives a really good picture as to the platform we have built and where we're going. So what we're sharing with you is solving existing problems and old world problems with a new methodology with real-time fact data, but building out a platform that will take us into the future to think about next problems to solve for our clients, especially the ones we don't know that we don't know. So what we're seeing is a lot of emergent technology coming into retail petroleum around loyalty systems and queuing, managing queues for cars, managing payless transactions, managing walk-in payless transactions. It's quite significant. And also the other piece that has been a latent technology is CCTV. So what it comes down to is building an integrated platform that can knit things together, that is agnostic in terms of manufacturer and brand of equipment on site, and agnostic at the hardware level or the physical layer. I'm going to show you an example now of what we're doing here. And this is what Zoran was talking to. It's, now we're in a position where we can apply data science because we have this richness of fact, real-time data that we can do something with. And we're building data lakes of data that is quite extensive to model. So this is an example of machine learning with an incident on site that obviously can be quite catastrophic. So the next journey for us, and before we go to Q&A, is we've entered into a research agreement with DiUS and RMIT that will allow us to bring more horsepower to our journey into the data science and how we can apply data science to solve not only the problems we've shown today, but problems into the future. So I'll hand over now to Cameron and to continue the presentation.
Thank you, Zoran. Thank you, Russell, for an amazing presentation. Before we get to the Q&A, I did want to mention here that DiUS, in partnership with EMS, has done great work in terms of leveraging IoT to gather data autonomously to deliver great value. However, DiUS is offering now to book a 2-hour complimentary deep dive to find out how this could help you as well. So if you want to, if you're interested in that, please either get the URL from the PowerPoint, or you can scan the QR code. I'll give you a second to do that before we start addressing some of the questions. I think while people are noting that down, I will start with the Q&A. So first question we have for Russell: does the legislation require immediate reporting to EPA in each country? And if not, can the platform expand for such reporting?
The first answer is it varies country to country, but there is a time frame usually on once you've validated you've had a loss of containment, you then need to notify. In Australia, for example, it does change state by state. In the US, it's again state by state, so it varies. What I can see emerging is that will become sort of virtually in real time. Sorry, and the second question you had, the second part of that question was, just remind me.
And if not, can the platform expand for such reporting?
Yes, it can.
Okay.
That's right. So with regard to leak detection, we can move to what we call dynamic or real-time leak detection because we have the data platform to support that. So that's not what we're doing right now. That is to come, and that's probably going to be another year or two journey with our research engagement to unlock what we can do with that data to find leaks faster and sooner.
Okay. We do have a lot of questions, so I'll try to go through as many as we can in the short time that we have. The next question for Zoran is: how do you cater for IoT outages? That is, an IoT device stops, for example, IoT device X stops reporting.
Sure. So I guess it really is an overall system capability that you're building there. So firstly, it's to understand that there's actually an outage. So that's the first point. So whatever your cloud infrastructure is, it needs to be telling you that there's an outage. And for the most part, you also need to build the capability of the devices that they can actually cope with an outage. So if there is intermittent connectivity, the end devices can continue on. Now, what we normally build in those devices, we build real-time clocks, so they can actually so the device can continue to operate and continue to accept data. We have some local storage capability, and then once the outage actually, concludes and you've got comms back, you can actually upload that data reliably.
All right, thank you for that, Zoran. Next question for Russell: is Fuelsuite available in languages other than English?
At the moment, no. Yes, Chinese, but we haven't implemented other languages at this point.
Okay, great. And another question for you, Russell. Firstly, they start off with thanking you and saying that it was a great presentation. They're keen to understand in the slide about the convergence of all the customer problems, Was your sales pitch to fuel sites driven by any one main bubble, that is compliance or customer journey? And if they were different, how did you prioritize your build?
Okay, that's a good question, but a hard one to answer. Because we had to look at all the individual cases in that business case that we put together. So it was a case of packing and unpacking and looking at our differentiation and our pitch. So really what we're showing there is the consolidated view of the value proposition, but customer by customer, that can be quite different. So I guess when it comes to the pitch, what we focus on is what does the customer want to achieve first and foremost, and then pairing back our solution so it's just enough to give them what they want without having to pay for what they don't need, but also gives them the extensibility to later on take that up if they need.
Okay, thank you so much. Question for Zoran. In respect to proprietary protocols, how do you handle vendors upgrading their devices, pumps, etc.?
Look, that's a really good question. It really means that whatever we do, we need to be able to upgrade remotely. So the station data aggregator that we have, essentially that's the central component at the remote end, is fully upgradable. So as protocols come along, as they change, essentially they can be upgraded.
Okay, thank you. I guess this is for Russell. Did you have to get any new equipment certified to work with Fuelsuite?
Yes, well, our edge hardware that we refer to as FuelScan, that's the brand of the device. The small form factor computer that we partnered with Advantech already had the required electrical certifications for the target markets we were operating in. And the DiUS team who designed and helped us through POC piloting and right through to production of the PCM, that's the pump communications module, that was designed and built here in Australia. We put that through with DiUS through the relevant testing for the environment that it's in and has full compliance.
Okay. All right, thank you. A question for Zoran. Whilst you're providing real-time analysis on IoT data, I think you answered this as well, but there's another question around this. Are you retaining the data for later analysis as a value add? And how long are you retaining the full data set?
Oh, that's a good question. I might actually defer to Russell. I'm not sure how long we're keeping the data there.
Yeah,
we are keeping the data for some time. I'd have to actually go back and really just check to see the duration. Look, that sort of thing is actually adjustable. It really depends on your data retention policy. So, you know, we've seen clients where, you know, they keep data for many years. Other industries we've seen, you know, they keep data for 2 years. Again, it just depends on your data retention policy. All of that is configurable and adjustable.
That's right. But to answer, to give you some specifics, the key areas in our platform that require data retention retain from 1, 3, 5, and 7 years, and mostly that's driven by the compliance requirement. So, but as Zoran said, we can set that up however we choose. So up to 7 years.
Okay. All right. Thank you. Does the Fuelsuite use any CCTV data as well?
Yes, we're looking at that at the moment as an integration point, and that was the last slides we've shown where we're looking at CCT data streams and applying machine learning to that. Is it a fully integrated solution at the moment? No, but we can connect at the edge and move that data into the cloud and pick and store the data we want, or we can look at the time frame data at the CCT edge, depending on what it has as a, you know, DVR or whatever it might have and how long it retains information.
Okay. Couple more questions for you, Russell. Does someone from EMS team need to visit each petrol station, or does any equipment get couriered to a site and then the station operator installs it?
Sure. So FuelScan, the edge hardware is plug and play. So we normally ship that to an electrical contractor and they will install it on site, keeping in mind that if you want to work on a petrol station electrically, you need to have certain qualifications. So it's not something anyone can do. But having said that, when we designed the device, it was designed that anyone could actually replace it at a site level. But almost every oil company will only allow an electrical contractor to do that. So we don't need to step on site. It is very simple to install.
Okay. All right. Another question for you. What's next for Fuelsuite? Other markets, other industries?
Yeah, sure. So one unintended outcome of Fuelsuite was that we didn't expect, because we've built a cloud true IoT platform from an edge device. The extensibility of it is quite amazing. We've been approached by power companies, by water companies, a range of alternate markets that we honestly didn't think about. And of course, we just have to be a little bit pragmatic, and before we go chasing everything, we need to focus on what we probably do best. So yes, we are looking at alternate options in terms of white labeling, or allowing the solution to be used in other applications. Are we going overseas? Yes, absolutely. We're piloting in various markets with fairly rapid scaling.
All right, thank you. I think this is more for Zoran. How are your AWS resources managed? That is, creating device shadows for your things and others.
Well, I guess in terms of the actual day-to-day management, our partnership with EMS is really the way that we've worked it is that we provide a lot of the development grunt. So whenever there's a major uplift, we'll go in and help Russell with a new development. And then what we have done in the process is really to upskill his people so they could then go and sort of run the day-to-day operations of their cloud service and so forth.
Yes, I guess just to extend on that, Cameron, is we have our own in-house research and development team. So they manage the AWS infrastructure and now the entire Fuelsuite development going forward. And DiUS support us in two ways: our edge solution when we need to implement protocols, and when we have a rapid development sprint where we need 5, 10, 12 developers, we can draw on DiUS's teams, whether that is a blended team of UX, UI, front end, back end, whatever it might be. So it allows us to stand up teams and stand them back down rapidly.
Okay. I think this will probably be the last question. It's more around best practice, I would say. So does the delivery of a fuel to a service station agitate any sediments in the storage tanks? And the question is, should I avoid filling my car if I see that there's a delivery in progress?
Well, that's a really good question. I've always said to my wife, if you see a truck on site, move on. And simply not because it's not safe, it's just that it's a hazardous environment. And so that's my personal point of view. Will a delivery agitate sludge in the bottom of the tank? If it's a pre-existing condition and it's there, and depending on the volume change in the tank, you can certainly get that. It's not uncommon to have sediment in the bottom of the tank and rust, but keeping in mind, the uplift of fuel from the tank to the dispenser to your hose has a number of filters in line that will remove that so you will get quality fuel.
Okay. Thank you for that. We do have a couple more questions. How do you see the move to electric vehicles will affect your business model, in particular in China and Europe?
Yeah, that's a really good question. So part of our platform solution has been taking up looking at EV charging integration into our solution. So I do have a view that electric vehicles will become a significant feature, but probably not for 25 years. If you look at the retail asset investment by major oils and the fact that they're running very fast at increasing their network size, most of them are toying with electric, but I think the consumer demand will change that. So we have a strategy to implement Monitor EV, as well as introducing Fuelsuite as if you think of it like electric suite, where we're monitoring a range of reactive loads, not just in a petrol environment, to provide a future for us, if you like, if that should be the case.
All right, thank you. I'll monitor the question. I think this might be the last question unless more pop in. Where does the IP lay with respect to each component of the edge solution and AWS services, etc.?
Russell, do you want to take that? Sorry. Or I'm happy to take it. I mean,
no, you can take it. I didn't quite catch the question, but I'm happy if you want to take it. Sorry.
Yeah, where does the intellectual property lay with respect to each component of the edge solution and the AWS service?
Okay, well, I can answer that at the commercial level, that they all reside with EMS.
Yeah, correct. So our business model, I guess, when we provide consultancy services, essentially, the IP resides fundamentally with our clients. Now, there are circumstances where we may bring something to the table, which is always declared and sort of we're upfront about that. But when we are engaged, as we are with Russell, in a partnership like this, the IP rests.
All right. Thank you so much, everybody. Thanks for all the great questions, and thanks to our panel for answering with such great insight. We will now be launching one last poll to obtain feedbacks on today's session. Please provide your feedback. So while you're entering, thanks for everyone for joining us today. We hope you got the insights you need to drive innovation within your business. We will send a recording of today's session in the next few business days. We look forward to seeing you at future events as well. Thank you.
Right. Thank you. Thank you, everyone.
Thank you.
Thank you.
Cheers.